Scaling monitoring across hundreds of microservices or tenants using static dashboards is unsustainable. Every new service requires duplicating and modifying the dashboard configuration, leading to maintenance debt. The solution is immediate templating. Grafana variables allow a single dashboard definition to serve as a dynamic template, filtering the underlying data source based on user selection. We begin by defining the two primary variable types, query and custom. Query variables dynamically fetch values, such as service names or host identifiers, directly from the connected data source, typically Prometheus or Postgres. Custom variables are defined manually within Grafana, useful for static configuration parameters, like environment names or predefined thresholds. Understanding this distinction dictates the refresh strategy and data source interaction required for effective ITSM visualization. To implement a query variable, navigate to Dashboard Settings, then Variables, and select Add Variable. The critical step is defining the data source and the query itself. For Prometheus, use the label_values function, for example, label values up instance, to retrieve all unique instance labels from the up metric. For SQL data sources, the syntax is a standard select distinct statement, such as select distinct service name from incident table. Ensure the refresh setting is configured to on dashboard load or on time range change, depending on the volatility of the underlying data. Setting the refresh interval too aggressively can overload the data source, impacting overall system performance. Always test the query output immediately using the Preview of Values section before saving the variable definition. Enabling the multi-value option transforms the variable output from a single string into an array of selected values. This is essential when analyzing aggregated performance across multiple components simultaneously. When multi-value is active, the query syntax must adapt to handle the array. In PromQL, use the special variable syntax /variable to automatically format the selection into a regex expression suitable for label matching, such as instance equals regex/instance. For SQL, use the in operator with the variable enclosed in double brackets, like where service ID in double brackets /service ID. The include all option automatically generates a special value that, when selected, bypasses the filtering condition, effectively showing all data. This all value must be explicitly handled in the query logic, often by using a conditional regex or a specific SQL clause. Chained variables establish a hierarchical filtering context, ensuring that the options available in a child variable are constrained by the selection made in the parent variable. For example, selecting a specific region should limit the available hosts to only those within that region. To implement chaining, the child variable's query must reference the parent variable using the $ syntax. If the parent variable is named region, the child variable SQL query becomes select distinct hostname from inventory where region equals /region. Grafana automatically re-executes the child query whenever the parent variable selection changes. This dependency mechanism is fundamental for building complex ITSM dashboards that drill down from high-level service tiers to specific component metrics. Ad hoc filters provide dynamic key-value filtering capabilities without requiring predefined variables. Unlike standard variables, which are defined globally, ad hoc filters are applied directly to the data source and automatically propagate across all panels using that specific data source. To enable this feature, define an ad hoc variable and select the target data source. Grafana automatically discovers available keys, typically metric labels in Prometheus or column names in SQL. When a user selects a filter, for example, environment equals production, Grafana injects this condition directly into every query executed against that data source. This is highly effective for rapid exploratory analysis, allowing system analysts to slice data instantly based on arbitrary metadata without modifying the dashboard structure.
The repetition feature allows system analysts to dynamically generate multiple panels or entire rows based on the value selected in a variable. This eliminates the need to manually create identical visualizations for every service component. To repeat a panel, navigate to the Panel Edit settings, then the General tab, and select the variable name in the Repeat section. If the variable has 5 selected values, Grafana renders 5 identical panels, each filtered by one of those values. Repeating an entire row is achieved similarly via the Row Options menu. Use the $__ series name variable within the panel title to dynamically label each repeated visualization, ensuring clarity and context for the displayed metrics. The syntax for embedding variables differs significantly based on the query language. In PromQL, use the $ prefix, such as rate of HTTP requests total with job equals $job 5M. If the variable is multi-value, Grafana automatically handles the regex formatting. For SQL, the standard format is double brackets, like select count star from logs where severity equals 2 angle brackets severity. However, when using the all option or multi-value in SQL, ensure the query logic correctly handles the resulting comma-separated list or the special all value. For example, if the variable is used in a like clause, you might need to manually construct the regex pattern within the SQL query itself, depending on the specific database dialect. Grafana provides several internal variables that offer context about the current dashboard state. The $___ interval variable is crucial for optimizing time series queries. It represents the calculated time span between data points, automatically adjusting based on the selected time range and panel width. Using $___ interval ensures that the data density remains appropriate, preventing excessive data fetching for long time ranges. For example, in PromQL, use rate of metric $___ interval. Other useful internal variables include $___ time filter, which injects the current time range as a where clause in SQL, and $___ user, providing context about the currently logged in user for access control or auditing purposes. Consider an ITSM scenario where we need to analyze incident response times based on service tier. First, define a query variable named service tier, fetching values like gold, silver, and bronze from the incident database. Next, define a chained variable named component, filtered by the selected service tier. The dashboard panels then use both variables. A panel showing average resolution time uses a query like select average resolution time from incidents where tier equals $service tier and component equals $component. By enabling multi-value on the component variable and using the repetition feature on the row, system analysts can instantly compare resolution times across all selected components within a specific service tier, providing immediate operational insight. Variable performance directly impacts dashboard load time. Optimize variable queries by ensuring they are highly selective and indexed in the underlying data source. For variables that rarely change, such as a list of environments, set the refresh trigger to never or on dashboard load, avoiding unnecessary query execution during user interaction. For high-cardinality variables, consider using the regex field within the variable definition to filter the return values before they are displayed, reducing the drop-down list size and improving user experience. Finally, always verify that the variable query execution time is minimal, ideally under 100 milliseconds, to maintain a responsive analytical environment.